Hey y'all, today is Tuesday, September 14th, and we are working on lesson 110. 110, the lesson title is Solve Problems with Rational Numbers. So we could be adding, subtracting, multiplying, or dividing with rational numbers. So let's get started. Skip page 65 and go on to page 66. Looking at example 1. Water drains steadily out of a lock to lower a boat from one level to another. What is the boat's change in position each minute? So, looking at our picture, we have some key information. We see that the boat lowers 3 feet. So what integer represents that it lowers 3 feet? I hope you said -3. Okay, we also know that it takes the boat 4.5 minutes to lower that distance. So to figure out the change in position each minute, we can simply divide. The total change in position we know is -3, and I can divide that by how long it takes the boat to lower that distance. So -3 divided by 4.5. Well, I'm going to start by rewriting this so I have two fractions. So -3 I'm going to rewrite as -3/1 and divided by, and then I'm going to convert 4.5 to an improper fraction. So 2 times 4 is 8, plus 1 is 9. So I have 9/2. Now at this point I've got two fractions, so I can use keep, change, flip. So I'm going to keep my first one exactly as it is, -3/1. I'm going to change division to multiplication, and I'm going to flip my second fraction. So it's going to become 2/9. Now I'm going to ask myself if anything here can be reduced. 2 and 1, I can't reduce anything, but 3 and 9 do have a common factor. 3 goes into 3 one time, 3 goes into 9 3 times. So now that I've done that, I'm ready to multiply, and I just multiply across the top. 1 times 2 is 2, and then 1 times 3 is 3, and don't forget to make it negative because we had two different signs. So -2/3 is our answer. Now what does that mean? It means that the boat lowers 2/3 of a foot each minute. The boat lowers 2/3 of a foot each minute. Okay, let's look at try it down here. A weather balloon ascended from an elevation of 18 feet below sea level to an elevation of 19.5 feet above sea level. What distance did the weather balloon rise? Okay, so I've already underlined that word distance, but I'm going to highlight it as well. Distance is important because I need to remember that distance is always positive. So no matter what, I need my answer to be positive here. I also put that ascended means that it is rising, it is moving upwards. So for me to understand this one, I thought it was best to draw a picture. So that's what I did right here. We know that the weather balloon starts at an elevation of 18 feet below sea level. Well, what does that mean, 18 feet below sea level? Well, hopefully you understand that that means that it starts down here at -18 feet. Okay, and it ascends, it rises to an elevation of 19.5 feet above sea level. Okay, so we want to know the total distance that it rose. So I'm going to have to add these two distances together. And I know that where this water is, that distance, or that is 0. So what is the distance from -18 to 0? In other words, what is the absolute value of -18? Well, it's 18. Okay, what is the absolute value from 0, or sorry, what is the distance from 0 to 19.5? In other words, what is the absolute value of 19.5? Well, it is 19.5. So now that I have my two absolute values, I can add them together. So I'm adding 18 plus 19 and 1/2. So what I'm going to do is I'm actually going to stack 18 and 19 together. And I'm going to add them. 8 plus 9, that's going to give me 17. And then 1 plus 1 plus 1 gives me 3. So I'm going to have 37. And then I need to tack this half onto that. So my answer is 37.5 feet. That's how far the balloon rose, 37.5 feet. Moving on to page 67. Kevin played a trivia game. Each correct answer is worth 2 1/4 points, and each incorrect answer is worth -1/2 point. What was Kevin's score? So we're going to look over here at this little phone, and we can see that he answered 15 correct answers and 15 incorrect answers. So to solve this problem, we're going to multiply the number of correct answers with the points that he earned for each correct answer. So he answered 15 questions correctly, and for each one he earned 2 1/4 points. Now, he also answered 15 questions incorrectly, and he lost 1/2 point for each of those. So we're going to add to this another multiplication expression where we multiply the number of questions he answered incorrectly with the number of points that he lost for each one of those incorrect answers. And now we're just going to solve this piece by piece. So let's start with this first piece here. So I'm going to rewrite 15 as a fraction. So 15 over 1. And I'm going to multiply that with another fraction. And I'm going to go ahead and change this mixed number to an improper fraction. So 4 times 2 is 8, plus 1 is 9. So I have 9 over 4. Okay, before I move on, I'm going to do the same thing over here. So 15 I'm going to write as 15 over 1. And then I have -1/2 being multiplied with that. So now we're ready to multiply each side. So I'm going to see if anything reduces. 9 and 1, 15 and 4, nothing here reduces. So I actually need to multiply 15 times 9 together. So let's see if I can find some room. 15 times 9. 9 times 5 is 45, carry your 4. 9 times 1 is 9, plus 4 is 13. So I get 135. So 135 on the top and 4 on the bottom. Plus, let's see what we have over here. Does anything reduce? Nope, it doesn't look like it. So we're going to have 15 times 1, that's 15. And then 1 times 2, that's 2. And remember, this one needs to be negative. Okay, so now we're just adding 2 fractions together. But I have one problem. I don't have the same denominator, and I really need the same denominator. So I'm going to change this one here so that I have the same 4 in the denominator. So how can I do that? Well, I know that 2 times 2 makes 4, so I'll just multiply my numerator times 2 as well. So we have 135 over 4 plus -30 over 4. So now that we have the same denominator, all we have to focus on is what's in our numerators. So 135 plus -30. Well, because one's positive and one's negative, I'm going to subtract. So we really have 135 minus 30. 5 minus 0 is 5. 13 minus 3 is 10. So I get 105, and it should be positive because my bigger number is positive, over 4. Now, this right here is a correct answer, but it's an improper fraction, and we don't really record points this way when we're playing games. So let's change it so that we have a mixed number. So to do that, we're going to divide. So 4 goes into 105 how many times? Well, 4 goes into 10 2 times. 2 times 4 is 8. When I subtract, I get 2, and I'm going to bring down this 5. 4 goes into 25 6 times. 6 times 4 is 24. When I subtract, I get a 1. And right there, I have enough information to write my mixed number. My whole is this 26 right here. My part becomes my numerator, 1, and 4 stays the denominator. So 26 and 1/4 points is how many points Kevin has. 26 and 1/4 points. Okay, moving on to try it. Rashida had 18 correct answers and 12 incorrect answers. What was Rashida's score? So same game. For those 18 correct answers, she got 2 and 1/4 points. And for those 12 incorrect answers, she got -1/2 point for each of those. Okay, so we're going to do the same thing, and we're just going to multiply and then add together. So she answered 18 questions correctly and got 2 and 1/4 points for each of those. And she also answered 12 questions, but they were incorrect, so she lost 1/2 point for each of those. So let's start with our first part, the part that's on the left side of the plus sign. I'm going to write 18 as a fraction, so it'll be 18 over 1. And I'm going to multiply that with 2 and 1/4 as an improper fraction. So 4 times 2 is 8, plus 1 is 9, so 9 over 4. And I'm going to do the same thing over here. 12 over 1 times -1/2. Okay, now when I look to see if anything reduces on the left-hand side, 18 and 4, I can reduce. I can make those 2's. So 2 goes into 4 2 times. 2 goes into 18 9 times. So now that I've reduced that, I can multiply. We've got 9 times 9, that's 81. And then 1 times 2 is 2. So I have 81 over 2. Now let's move on to the right-hand side of the plus sign. So I see that I can reduce, but I don't really want to because I have a 2 right here. And if I can just keep it to where I have a 2 in my denominator, that would be super, super helpful. And I know that if I don't reduce anything, because I'm multiplying 1 times 2, I'll have a 2 in my denominator. So I'm not going to reduce anything here. So we know that 12 times 1 is 12. And then 1 times 2 is 2, and it needs to be negative. Okay, so like I said, now we have a common denominator. So all we have to do is focus on our numerators. So we've got 81 plus -12. Well, one's positive and one's negative, so I'm going to subtract those integers. So 81 minus 12. I can't take 2 away from 1, so I'm going to borrow. This 8 becomes a 7, and that 1 becomes an 11. 11 minus 2 is 9. 7 minus 1 is 6. So I'm going to have 69 over 2. Now, this right here, it should be positive, and it's an improper fraction. It's correct answer. However, we don't really record points in this format, so let's make it a mixed number. To do that, we're going to divide. So we're going to figure out how many times 2 goes into 69. 2 goes into 6 3 times, which is 6 exactly. So I'm going to bring down this 9. 2 goes into 9 4 times. 4 times 2 is 8. When I subtract, I get a 1. So right now, I have enough information to write my mixed number. 34 is my whole. And then I have 1/2. So 34.5 points is how many points Rashida has. Okay. Moving on to example 3. The temperature at 4 p.m. was 2.5 degrees Fahrenheit. It dropped 0.75 degrees each hour for the next 4 hours. What was the temperature at 8 p.m.? So I'm going to do this in 2 steps. First, I'm going to figure out the total change in the temperature. So I know it drops 0.75 degrees. So because it's dropping that much, negative 0.75 is the rational number that I'm going to use. And it dropped that amount each hour for the next 4 hours. So I'm going to multiply that times 4. Now, this is one I don't know off the top of my head, so I'm actually going to stack them. So 0.75 times 4. Before I do anything, I do know that my answer is negative because I have 2 different signs. I'm going to go ahead and put that negative sign there. Now, 4 times 5 is 20. 4 times 7 is 28, plus 2 makes 30. 4 times 0 is 0, plus 3 makes 3. Now, right now, that's where our decimal point is, but because I have 2 decimal places, I need to move it 2 places over, so it's going to go right behind that 3. Oops. Right behind that 3 right there. So the total change in temperature is negative 3 degrees Fahrenheit. So now we're going to add that to the starting temperature. And it started at 2.5 degrees Fahrenheit. So we have 2.5 plus negative 3. And that's going to tell us what the temperature is at 8 p.m. Well, I see that I have 2 different signs, so I'm really going to subtract. So which of these numbers is farther away from 0? 3. So I'm going to write this as 3.0, and I'm going to subtract 2.5 from that. I can't take 5 away from 0, so I am going to borrow. 3 becomes a 2, 0 becomes a 10. Now 10 minus 5 is 5. I'm going to bring down my decimal point, and 2 minus 2 is 0. So I have 0.5, but what kind of 0.5 do I have? Well, hopefully you said I have a negative 0.5 because my bigger number is negative. So negative 0.5 degrees Fahrenheit is our temperature at 8 p.m. Let's see if we can try it down here. The temperature at 10 a.m. was negative 3 degrees Fahrenheit and increased 2.25 degrees Fahrenheit each hour for the next 5 hours. What was the temperature at 3 p.m.? Okay, so 2 pieces here. Let's first figure out our total change in temperature. So the temperature increases 2.25 degrees. So 2.25 needs to be positive because it's increasing. And it increases that amount for the next 5 hours. So I'm going to multiply that times 5. So I don't know this off the top of my head, so I'm going to stack. And what I do know about my answer before I do any math is that my answer is going to be positive because both of my numbers have the same sign. So 5 times 5 is 25. 5 times 2 is 10, plus 2 makes 12. And 5 times 2 is 10, plus 1 makes 11. So right now that's where our decimal point is, but I've got 2 decimal places in my problem. So I'm going to move that decimal 2 places over. So it's going to go in between that 11 and that 2. So the total change in temperature is 11.25 degrees. So now I'm just going to add that to our starting temperature. So our starting temperature was negative 3 degrees Fahrenheit. So we add that to the 11.25 change, and that's going to tell us what our new temperature is at 3 p.m. Now what I notice here is that my numbers have different signs, so I really need to subtract them. So which one is farther away from 0? Well, 11.25 is farther away. It has a greater absolute value. So 11.25 I'm going to stack on top, and then 3, I'm going to put underneath that. But remember, I need to write it like this because we have to line up our decimals. So 5 minus 0 is 5. 2 minus 0 is 2. Bring down your decimal. 11 minus 3 is 8. So, should it be positive or negative? 8.25. Well, hopefully you said positive because our bigger number is positive. The term with the greater absolute value is positive. So, the new temperature at 3 p.m. is 8.25 degrees Fahrenheit. Moving on to page 68. We're going to skip 1, 2, and 3, but we are going to work on numbers 4, 5, and 6. So, number 4. Kara had a savings account balance of $153 on Monday. On Tuesday, she had 6 withdrawals of $15.72 and a deposit of $235.15. What was her account balance after these transactions? Okay, so I'm first going to figure out how much total money she took out. So which word means that she took out money? Well, withdrawals. That means that she's taking money out. So when she's taking that much money out, should that money amount be represented with a positive or negative number? Hopefully you said negative. So we're going to use negative 15.72. And we're going to multiply that with 6 because she had 6 withdrawals. And we know that our answer here is going to be negative. Okay? So I don't know this off the top of my head, so let's stack 15.72 times 6. 6 times 2 is 12. 6 times 7 is 42 plus 1 is 43. 6 times 5 is 30 plus 4 is 34. And 6 times 1 is 6 plus 3 is 9. Now, where do we put our decimal? I've got 2 decimal places in my problem, so I move it 2 places over. So it goes right there. So negative 1572 times 6 is negative 94.32. That's how much money she took out. Now, she also added. How do I know she added money to her account? Well, there's a deposit of $235.15. So I can add $235.15 to her account too. But let's take what she started with first. She started with $153, and then she had her withdrawals that totaled negative $94.32. And then she deposited, so she added back in $235.15. So let's just work our way from left to right because that's how we read. So let's focus on these 2 right here. Well, one's positive and one's negative. So we're going to really subtract. So which one is farther away from 0? Well, 153 is farther away from 0. So 153.00 is how I'm going to write it because I have to line up my decimals, minus 94.32. Now, I can't take 2 away from 0, so I'm going to have to borrow. And I'm going to go all the way to this 3 right here. The 3 is going to become a 2. This 0 becomes a 10, which then becomes a 9. And this one becomes a 10. 10 minus 2 is 8. 9 minus 3 is 6. Bring down your decimal. 2 minus 4 doesn't work. So this 15 becomes a 14, and that 2 becomes a 12. 12 minus 4 is 8. And then 14 minus 9 is going to be 5. So 58.68 is what was left in her account after she took the money out. But then she added $235.15. So we're going to take 58.68, and that should be positive because our bigger number was positive. And we're going to add $235.15 to that. So I see that I'm left with 2 positive rational numbers, so I'm just going to stack them and add them together. So it doesn't matter which one I put on top. So 2, 35, 15. And we're adding. Okay, 8 plus 5. 8 plus 5 is 13. 6 plus 1 plus 1 is going to be 8. Bring down your decimal. 8 plus 5 is 13. 1 plus 5 plus 3 is going to be 9. And then I'm going to bring down that 2. So I get 293.83. And it should be positive. So the amount in her bank account after everything is said and done is 293.83. Oops, I'm running out of room. 293.83. Okay, moving on to number 5. A scuba diver is swimming at the depth shown and then swims half a foot toward the surface every 3 seconds. What is the location of the scuba diver relative to the surface after 15 seconds? Okay, so we see in the picture right here that the scuba diver starts at negative 46 feet. So 46 feet below the surface of the water. Okay, and he swims a half a foot toward the surface every 3 seconds. So I'm first going to divide 0.5 divided by 3. Okay, but then I'm going to multiply that times 15, and that's going to tell me how far he swims up in 15 seconds. Now, here I have a fraction multiplied with a whole number. So let's rewrite this so I've got 2 fractions multiplied together. So 0.5 over 3 times 15 over 1. Well, can I reduce anything? Yes. So 3 and 15 have a common factor of 3. 3 goes into 3 1 time. 3 goes into 15 5 times. So now I can just multiply 0.5 times 5. 5 times 5 is 25. 5 times 0 is 0 plus 2 is 2. And I need to move my decimal just 1 place over, so it's 2.5. So what that means is that the diver swims up 2.5 feet. Okay? So let's take where he starts. He starts at negative 46 feet. And he swims up 2.5 feet. So if we add these two numbers together, we'll figure out where he is after 15 seconds. So what I see is I've got 2 numbers with different signs. So I'm really going to subtract. So which number is bigger? Which one is farther away from 0? 46. So I'm going to put that one on top. So 46.0 minus 2.5. I cannot take 5 away from 0, so we'll borrow. 6 becomes a 5. 0 becomes a 10. 10 minus 5 is 5. Bring down your decimal. 5 minus 2 is 3. And I have a 4. So should it be positive or negative? Well, it should be negative because our bigger number is negative. So negative 43.5 feet is where the diver is after 15 seconds of swimming upwards. Number 6, the temperature of a cup of coffee changed by negative 54 degrees Fahrenheit over 22.5 minutes. What was the change in the temperature each minute? So it changed by negative 54 degrees Fahrenheit. So I'm going to start with that. And it changed over 22.5 minutes. So to figure out the change in just 1 minute, I'm going to divide these numbers. So I'm going to rewrite this as division. So we start with negative 54 divided by 22.5. So let's write both of these numbers as fractions. So we have negative 54 over 1 divided by, now let's write this as an improper fraction. 2 times 22 is 44, plus 1 is 45. So 45 over 2. Now that they're both fractions, we can do keep, change, flip. So we have negative 54 over 1. We keep that one. We change division to multiplication, and we flip this one here, so it becomes 2 over 45. Now, does anything here reduce? 1 and 2 we can't reduce, but 54 and 45 we can. In fact, 9 goes into both of those. We know that 9 goes into 45 5 times, and 9 goes into 54 6 times. So now that we've reduced, we're ready to multiply. We know that 6 times 2 is 12, and then 1 times 5 is 5, and it should be negative because they had different signs. So negative 12 over 5 is the change in just 1 minute. Now, this right here is an improper fraction. Let's see if we can write this as either a mixed number or as a decimal. Well, the way I'm going to do that is with long division. So 12 goes on the inside, 5 on the outside. 5 goes into 12 2 times. 5 times 2 is 10. When I subtract, I get a 2. So I'm going to add a decimal and a 0 and continue. So 5 goes into 20 4 times. 4 times 5 is 20. So there is no remainder, and this decimal terminates. So 2.4 or negative 2.4 is the change in temperature each minute. And if you had wrote it as a mixed number, you would have had negative 2 and 2/5. So that is the end of our lesson for today. For homework, I want you to answer questions 7 through 11 on page 69. 7 through 11 on page 69.